All right, welcome to another coding session. Today we're going to get stuck into some flow control. So that's like if statements. If statements can actually be a little bit complex because we've got if, and then you've got else if and else. So there's a bit of branching going on there. And then there's also for loops. Or I think I'm going to do the same as what Odin did. I'm just copying some where I don't have, much of an opinion. I'm just going to kind of copy what Odin did. Probably a little bit incorrectly. I'm going to copy what I think Odin did, which is probably wrong. We'll see how far we get, in a single episode. But maybe I'll go into a little bit of how something like if let's say we'll just have like a basic loop here. Maybe I can do it in the source file actually. Maybe that makes more sense than using that there. So what we kind of want to do is go like if result, then we can say like result equals 2, something along those lines. And here, because we don't have booleans or any concept like that, basically we're checking whether the result is 0 or not. 0 is considered false, anything else is considered true. That's how we're going to handle it at the moment. And something like this, maybe we'll take it over here because this this Excalibur is it's kept for posterity. You can always come back here. Go away, email and notifications. So we can go like result equals 4, and then we would not expect this loop to be entered. So this is in Bangalang, our language that we're creating. We have something like this. We declare a variable of 4, and we say if result, then result is true. Then we should see that the result is still 4. No, we should see that it's 2, because result is not 0, which means that it is true. Now, in assembly, how is that going to look? How do you do branching in assembly? Assembly doesn't have a concept of if statements. Assembly has a concept of labels. So you can have a line like this, my label, and then the indenting here is just a convention that I use. It doesn't actually mean anything, but you can have like, add 2 registers like that. And so let's make it a bit more relevant to an if. So what we can do is we can say, like say result is in if R9 equals result, so R9 is a register, let's say it's in that register. I just randomly picked that one because last episode we were playing with the numbers. Then we can say like compare R9 to 0. And in assembly, when you do a compare, what happens is it sets some internal flags, which then you can use to do jumps. So JZ means jump 0, jump if 0. And I have actually, so what compare actually does, oh, I spelled compare wrong. What compare actually does is it subtracts one from the other, and then depending on what the result is, it sets some flags. So here, R9 is 4, that's 0. So if you return, if you subtract 0 from 4, you're going to get 4, and that's not 0. So I can't remember what the internal flags are, and I guess it's not that important. It's just you have to do this first and then do jump 0, and we know it's the result is not 0, so it would have set a flag, and then we can just go jump to if end. Otherwise, we can say like move R9 2. So that's putting the result of 2 into R9. So you can see here, it's like if it was false, you know, if it evaluated to 0, which is what we're saying is false, then we jump to if end, jump to this label, and just continue working here. If it is true, I mean, no, if it's not 0, then it doesn't. The jump does nothing. So it's going to continue, and it's going to continue with this instruction, and then the label doesn't. You know, it's just going to keep going past the label, and it's going to execute this instruction and keep going and going. So effectively, this is just saying jump over this line if the value is 0. I think there is another way you can do this. I've seen test R9, which looks a bit weird. Let's have a look at that. The test instruction. Ooh, in Wikipedia even. Test operation clears the flags. These are the flags I was talking about. CF and OF to 0. If the result is 0, then ZF is set to 1. Otherwise set to 0. Yeah, so ZF, I guess, is the 0 flag. So it doesn't AND. It looks like. Set ZF if AL and, so the two operands. If that and that equals 0, then set the 0 flag. Makes sense. So is that all it does? Because it says here, well, I guess this is kind of a reset, right? It sets everything to 0. And then it sets that one if it's 1. So I feel like that might actually make a little bit more sense, because this comparison doesn't really make sense. Well, I guess comparing to 0 does, but this also doesn't make sense because we put two operands when we don't really need to. I don't know. Everything feels a little bit weird in assembly. But here we go. This is how you do an if, and it's all based around these jumps and labels. Basically, there's different jumps that have different conditions, but in the case of our if, JZ is basically what we want. So if we want to implement this, if we want to have this if loop, what are we going to need to do? Well, in our Bangalang language, this is our first keyword, I believe. And we currently have down the bottom here, we have this, which loops through and finds a number, and this one loops through and finds an identifier. Or we're assuming it's identifier right now. I'm thinking what we're going to do, because this is for tokens that start with a letter or an underscore. I think we're going to sort of let this loop play out, and then we're going to say if the result, the value of the resulting token matches something out of matches something in our keyword list, then we're going to call it a keyword instead of an identifier. And actually something I had thought about that maybe while we're here we can fix is that if I take this off, we would expect there to be an error because the statement is not completed, right? But I think that I'm probably going to have to take this out for this test. Unexpected end of file. Oh, so it's actually not that bad. What if I do this one? Unexpected end of file. Oh, wait a minute. I think it's because we have the new line. If I take away the new line as well, there we go. We get an index out of range, which I would prefer not to get. I would prefer to get the previous error. And that's because when we do this loop, we never check. We're advancing through the source, but we're never checking whether we've gone past the end, which we should probably do. So we should probably have, you know, a check here. Oops. No, I think it was here. I need to put all this stuff in brackets. And then I need to say index is less than the length of source. You know, just to make sure we're not crossing the line. And we do the same down here. And so I think that's going to be better. Now we get the error that we want. But I think with this one, no, we still get the one we want. But I still think there's maybe a better way to handle it. I think I would like to, instead of throwing this error here, I think I would just like to return a new token type. So there's an end of file token, info file. So here we've detected that it's into the stream, so we just go return end of file. Can I not do that? Type equals end of file. So then we get, yeah, expected closing bracket, found end of file, which is a better error message. And I think that's just down to the fact that we have better error messages in our tokenizer than we do in our, yeah, token stream returns nicer error messages. This one here. If you're expecting a certain token and you don't get it, then our parser does. I think we want to standardize that at some point. But at this point, I just wanted to sort of fix that bug. That was kind of it. Okay, so we can go back to where we were with our new if statement now. Now that we've completed that side quest, what I said we wanted to do was check against a list of keywords. So let me just scroll to the top here. Where does it make sense to put this? Put it here. Keywords is if is the only, whoops, I need to set up my keyboard. If is the only one. Need to say what type we're talking about here. So this is a slice, an Odin slice. We talked about these before. So a slice is just a view into a dynamic array, a fixed array, or in this case, it's kind of like a statically declared array thing, an array literal. I don't know. Anyway, a slice is kind of a nice generic thing that you can use to represent any of those. So now that we have that list of keywords, I think first we want to create our token like that, without a type. So we might need to go value equals or no, let's default to, oh, I'm not even in the right one, am I? That's the integer. Here we go, identifier. So default to identifier, and then we say for keyword in keywords, if token dot value equals keyword, then token type equals dot keyword. I haven't created that yet, have I? Keyword, and then here we just put in this token. Great. So now we have a keyword of if. Oh, we should probably take a step back and put this in our grammar. The grammar is really helpful for telling us where in the parser and where in the generation we need to add code. Because the code reflects the grammar a lot. Expressions are a bit special, but the rest of it is very close. So it's the token if. Oh, that reminds me that there is this exit. I want to divide this up because this is actually two tokens. The token exit and the bracket expression, another bracket. So the if is followed by an expression, and then followed by a scope. I think that's it. Yeah, I think that's it. Oh, and did that around the wrong way. And also it's a type of statement. So we need to add a case to our statement function when we parse a statement, and then we need to add an if function. So let's go to our parser. Here's parse statement. It's very convenient. And I'm a bit of a stickler about doing things alphabetically. So we'll do it like this. I guess we're talking about keyword here. If is the only keyword. We're kind of assuming we came across an if at the moment, but do we want to do anything about that right now? Maybe inside the parse if we will do something about that. So let's do a parse. I guess we don't need the whole thing, do we? Maybe we'll keep the top part because that's kind of useful. And we probably need a new node type that is an if. All right. And we need an empty return to keep Odin happy. So what did we say? First, the first token should be a keyword. And here's where I want to kind of verify. I was thinking we could maybe even extend this function, you know, so we can go like that. And then we can verify not only the type, but also the value. I kind of like that. I'm also a little bit curious if I just do that. No, doesn't work. Should we do that? Yeah, let's have a go at that. Next token of types. And this is like type and value. This is the Odin overloading syntax. You have to explicitly say that next token is like overloaded with these three functions. So when you use the procedure, when you call next token, it could route to any of these functions. So type and value takes a token type and a value. And then we don't need to loop here. We just say if, I think we basically say if type does not equal type, then we do this. Expected type, found type. Probably do the same down here. And here's the value, so we'll just say expected and found. So if I'm a bit of a stickler about this, but I like to put this on the left because it's sort of like this is the thing we're looking at and we're testing it against this. I don't know, that's the way I logically look at it. Maybe it's not that important, but that's how I like it. So we expected, so this is a value. So we expected this value, but we got this value. Okay. So then over in our parser, we should be able to go just put keyword if. Maybe in this context, we have to do token type. Yeah. Okay. Token type keyword. So we've verified that the first token is if. Next is an expression. So we're passing an expression. Which should give us an expression node, which we can then append to the children of our if node. Like so, and then we do something similar with a scope. Like so. I guess we could just do this, couldn't we? No, I think that's right. We've done it like this in other places because when we create a variable for it, then we see scope node. This kind of gives it a name. And then when we go to our generation, we can mirror that name, and it kind of makes it a bit easier to cross-reference and see what we're doing. But as far as parsing goes, I think that's it, because we already know how to parse an expression. We already know how to parse a scope. So we're just verifying there's an if at the start, and that's it. So generation, when we generate statement, now we want to have a case where it could be an if, and generate an if. And I guess this is where stuff's going to get interesting. can say if start, generate if. So what do we want to do? Let's grab out what we previously do. Yeah, we just sort of grab out the child nodes and give them their names. So it's expression node and scope node. And then we already know how to generate an expression. So I guess we pass in the file, the expression node, and the stack. We just called it parent stack for this scope function, but to differentiate it from the scope stack. Since a scope has its own stack. We'll change that in a minute because it is a bit weird. Now, I happen to know that generate expression will put its result in register 8, R8. I guess when we get to other platforms, we're going to have to do something a bit different, but that's how we do it with x86. So that means that we can get into this assembly here that we were talking about. This kind of thing. So if we do a print line, like so, we'll indent those. So actually it's R8. Testing R8 and R8, which is strange. And then we're jumping if 0 to if end. Now the thing here is that what if we have multiple if statements and they all have the label if end? I think that's going to cause issues because how does the assembler or the CPU or whatever, how does it know which if end to go to? So one thing we can do, I think, is put a dot on the front, and that kind of scopes it. I guess you could say it scopes it to the procedure. Which is the previous label. In assembly, that's just the previous label that I guess doesn't have a dot. So that's a bit of scoping. But then I think beyond that, we're also going to want to put an index in here. You know, like an if index, which we also want to put in here. So that's why it's starting to feel a bit weird. This is not really the stack. This if index doesn't really have anything to do with the stack. So I think I'm going to rename this to like a gen context. We can't just use the name context because that's already reserved in Odin. But now it's a gen context, and now everywhere that we have this stack thing going on, I'm pretty sure. Okay, so not everywhere do I want to replace this. It looks like basically everywhere. The only place that I don't want to replace this is in these comments, I think. You know, push to stack, clear scope stack. That's definitely still stack. But let's do a replace all. And then we can just restore these comments. Or did I just replace that with nothing? Okay. Let's try that again. I'm just going to use CTX as a shorthand for context, because again, I can't use the word context. So then no, stack. And stack. Okay, so now let's just add, it's like a context. And because it's a more generic context, I'm also going to make this, because this is to do with the stack, stack top, stack vars, and now if index we will add. So if index is going to be 0, and when we do go into a scope, because our scopes are just inline at the moment, you know, they're like this, or in the case of an if, like this. And that's not going to be enough to allow us to reset our if index. We want to continue the if index while we're in there. And in fact, now that I think about it, we want to keep maintaining that if index. So what I mean by that is when we enter a scope, we set the if index from the parent, which is what we're doing with all the other fields of it. Then we do the scope, which is a series of statements. And then at the end, I think what we want to do is then bring it back like this. We want the parent context to know that those if indexes have been used. Because like if there was a nested if in here and it's got the labels, right, in assembly, then when we come down here and we do another if, we need to respect the fact that there are already labels with that index. I hope this is not too hard to follow. Yeah, so I think those are the changes we need to make in there. And now we have the if index, that's great. At the end of our procedure, we're going to have to increment that so that next time there's an if, it takes a new index. Now we need to generate our scope. Oops. Generate scope. This time with the scope node. And then the last thing we need to do is actually create the label itself. Like so. All right, Eddie. Normally Eddie just sits down, so he shouldn't be too much. He shouldn't get in the way too much. So we've tested our expression. Of if when false. /0. I think that's it in terms of assembly. We generated our expression here. That's the first thing we do, right? First thing we need to know is what is the result of that expression. We know the expression goes into R8. The result goes into R8. So then we do a test with R8, which allows us to then jump based on the result of the test. And so if the result of the test is 0, if R8 was 0, then we jump to dot if index end. Otherwise, we generate the scope and we perform with those statements. I think that's about it. I think that looks good. We did put it up here. So then if we run this, we get exit code 0, which is very nice. Oh, here we go. Here's our if. So we're declaring, which does a very complex thing, which makes me think that it's this declaration here. Then we're moving the previous variable into R8, testing R8, jumping to if 0 end, which is down here, if R8 was 0. Otherwise, we assign to result the value 2. We put it in R8, then we assign it. And so at the end of the scope, we have this line where we free up the stack space, right? Because inside this scope, we could declare new variables, which will use more stack space. And then at the end of the scope, we can just move the stack pointer back. Because as we declare variables, it's moving that pointer forwards. And then we can just move the stack pointer back to effectively clear out those variables from the stack. But in this case, we haven't declared any variables in this scope, so we're just going back 0, which is pointless. And we haven't really done much in the way of optimization, but this just seems so pointless and so easy to get rid of that I'm going to do that. So if scope context size okay, so this was somewhere where I probably should have kept that variable name. Scope stack size equals 0. No, if it's greater than 0, was just to say if we actually declared something in that scope, then we do this. Otherwise, there's no need. So that makes our scope nice and simple. I think we have a previous scope up here, which still clears its space because it does have a declaration here. So that's great. So we should get, according to this, result should be true. So then result should get reassigned to 2, and we should get 2 as the oh boy. Looks like we're not getting anything yet. We've got some issues at 40. Division operator may only be applied to scalar values. Okay, what's not scalar about my value? I don't understand why my value is not scalar. But just in the interest of getting this sorted without too much trouble, let's try the other approach, comparing to 0. How does that work? Comma, colon, decorator, or end of line expected. I'm doing my comments wrong. So let's go back to this, because maybe the reason that was not working is because of the comments. Yeah. and we get 2. So that means that it went into the scope. So if I say result equals 0, then it should not go in here, and we should get an exit code of 0. Yeah? Because 0 is considered false. Zero. Nice. I guess the thing that's a bit tricky about that is like, no, because it would have got set to 2. I just want to double check something. If we don't do that at all, I have a sneaky suspicion. Oh, need to compile. Yeah, I thought we had a bug in here. I thought I remembered something about a bug. So that's not the value of result. Result is 20. And I have a feeling that it's because when we just quickly jumped in here and changed this to a push, I think what we actually needed to do was change the order of these. And I think the reason is, and I'm not entirely sure why this would have worked before, but I think the reason is that, so we push something onto the stack, but because we're starting from a high address and going to a low address, the start of the value is actually at 8, not 0. How can I visualize this? We have a stack here, right? Here's a stack. So if we have our stack pointer here, right, at the start, and this is address FFF. This is going to test my hex knowledge now. And this is the address. So if this is 8 bytes, what would that evaluate to, like that? FF8 maybe? Anyway, it's a lower number. This is hex, so this is a bigger number than this. So when we're at the start here and we allocate, we push this first thing onto the stack, because this is the lower number, it's kind of like this is, the stack pointer, the stack pointer moves up here once we put this on. And so it's pointing to this variable actually, because it's pointing to the start address of it, because this is the low address. So all this to say that when you push something onto the stack, wherever the top of the stack was before you pushed it, you need to add to that to get the address of what you just pushed. Yeah, and if I do this the other way around, then we're saying the address of the value we just pushed is at the bottom here. We're saying it's the FFF. So I think that was run the wrong way. If we run that again, we get 20, which is what we expected. So now in our source file, we put this back. Let's just confirm both ways again. So we get 2 because it went in here. And then if we set it to 0, we get 0. Result is 0. Cool. Okay, I'm happy with that now. Okay, we have a little bit of time left. So let's see if we can expand this a bit. I guess the next thing we can try is else. So optionally, expression, scope. So we start a group. Which is apparently not very happy about. Oh, we need to put the slash after. So we create a group with a question mark. So it's like an optional group. And inside that group, we have else, followed by another scope. So we can optionally do else scope. Okay, so we need a new token, a new keyword in our keyword list. If else, when we're parsing an if statement, we can say if peak token is a keyword I'm going to say value equals else. Let's just say that, because once we go in here and we consume the token, that's when we'll do a proper verification, right? We'll do this. So if we found else next, then we consume it and verify everything's okay here. And oops, if I can spell else. And then we do an else scope node. Yeah, I think the parsing, now that we have this peak token, next token business, parsing is really not very hard. It's really just a matter of looking at the grammar and saying, okay, what do we need to do? Well, we need to check if we have else, and if so, then we need to parse a scope. It's the generation where I think it's a bit more interesting still, because then I need to, it's where you really need to implement the logic, you know? So here's our if. This, we need to go after the else. This is the end, right? Well, actually, no. Yeah, we do still need that at the end. But we're going to generate an expression again. No, we don't need to generate an expression. So what do we need to do? I think after this here, we have another label, which is the else. Well, I guess it's if there are 3 children, you know, that these two, then we can get the else scope node, which is children 2. I think we'll put this up here actually. We'll say has else because I think we're going to need that in here as well. So if has else, we get the else scope node, and that's what we want to generate a scope for. And we also want to put a label before it, you know, to say this is where the else is. And up here is where we want to change this depending on whether there is an else node. So can I do a ternary? Looks like it. Okay, so if we have an else, then we want to go to the else label. Otherwise, we want to go to the end label. Right? If the test fails, but there is an else, then we do the else. If test fails and there is not an else, then we just go to the end. And the reason we need to have two labels like this is because at the end of our regular scope, we also need to have just a jump. So this is a non-conditional jump that goes to the end, right? So we do so if the test passed, then we will go into here and we'll perform our regular scope. And then if there's an else, we don't want to do that as well. You know, we want to jump over it. So we have jump to end. So that's kind of like skip else scope. And here we'll say skip main scope. Okay. I think that's it. I think that looks pretty good. So let's keep this one. And let's say if Z, let's say, oh, we use foo, Good old foo. We'll declare foo as 5, and then foo equals 3 times foo. Just some random stuff. And let's compile that and see what happens. Okay, so we have if0 and if1. So here's the first if. Got if start. I think if start scope I didn't indent, but I think if start I do want to. Scope start. I think it's just scope actually that has this start business. Start and end. Everything else is just saying what sort of statement it is. So here we go, if. So we put our variable into R8. We test if it's 0. Because here, I guess another thing we can test actually. What if we go Z plus 3? We should do something like that, right? We should have an expression there. Because this is just kind of the expression. This is evaluating the expression. That's all it has to do. So this is what we saw before. All looks good. And so if 0 is ended. Now we have our other if. So this is where we have like a variable Z, which I'm a bit concerned actually has gone to RSP plus 8. Oh, this is RSP plus 0. Okay, yeah, because we changed that. This is RSP plus 8. Okay. And so we put that into R10. R11 becomes the number 3. because we need to add them together. So then here's our add. We assign R10 to R8. Then we add R11 to it. So R8 has the sum of R10 and R11. Then we test R8. And if it was 0, we jump to the end. Oh, we didn't even do our else, did we? We didn't even do our else. So let's do an else. Else foo is assigned to 9. And actually, let's make this result so we can actually test it, right? Failed to generate declaration, duplicate identifier result, line 0, column 0. Okay, so that's incorrect. We have to do something about that. Yeah, so now we have else. Okay. So we already evaluated this, right? That's correct. So it will jump. So now this one's going to jump to the else, whereas the previous one, the if just jumps to end, right? But here, if it's 0, it's going to jump to else, where we're assigning 9. And this one we assign 8, and then we assign the sum of 3 and itself. So it's all looking pretty good, I think, and then we jump to the end. So let's run that and see. So I think the assembly looks pretty good. So we got 15. So what should it be? It should have skipped over this. But Z plus 3, Z was 10, no. Z gets assigned to Y, so Z is 77. 77 plus 3 is 80, which is not 0, so it should have gone into here, where it should have said result is 5, and then result is 3 times 5, which is 15. Yeah, okay. So if I go like minus 77, that should evaluate to 0, right? Which means that result should be 9. Result is 9. So we have if else. Nice. That wasn't so bad. That wasn't so bad. Do you think we can quickly knock out the else if? I mean, the else if I think is going to be a bit of a challenge. Maybe it's a bit more challenging than the other. Maybe we'll leave that for the next episode because that's a bit of a challenge, I think. We did complete a few side quests along the way. We did come across this issue. Line 0, column 0, which is not so nice. That's the duplicate identifier, which is here. So the left-hand side node doesn't have metadata, it looks like. So when we're parsing our declaration, we create a left-hand side node, and it doesn't have metadata. Yeah. Oh, here's the token, actually. There's the token. I do think we should probably get a shorthand for this. A shorthand for like creating a node from a token. Because there are some, like this is identifier to identifier, so that's obvious, where we can, I think we should map the type, and also we can just copy across the line number and the column number. And I think we can just take these out now that we're assigning all the values. Or are we assigning all the values? We're not assigning children. That was before. Is it going to let me just do that? Yeah. Okay. Doesn't have any children. So I think that's resolved it for that. Is there anywhere else that we create a token? Let's start from the top, shall we? Not there, not there. Oh, we create a node, sorry. We create this node, obviously. Create this node. Create this node. And this is the one we just took care of. Yeah, I thought this one would also be similar. Exactly the same, in fact. The right-hand node we don't create here. So we create this node. Okay. Here we create these operator nodes. And we are putting the metadata, so that's great. Oops. And when we parse our primary, we must be creating some nodes in here. Well, this node, this negate node doesn't have metadata. Oh, wait a minute. But that's, I feel like we can do that up here. So whatever the next token is, we use its line number and column number. So that covers this case. If we do something like this, then parse expression should have assigned it anyway. Yeah, so it gets assigned there anyway. So that's all good. Go away emails. Maybe I should turn that off when I'm recording. Here's another token that we create. No. Yeah, that's the, we just call that token. I feel like that's the, what is this for? This is the primary. Yeah, okay, just calling it tokens enough. And here we assign other stuff to node. Yeah, I think that should be enough. Yeah, now we get line 28, column 5, which is correct. Great. Okay, so we just managed to fix that up. Okay, so we have if else. Not bad. Not bad. I'm pretty happy with that. All right. That'll do for now. I think next time we'll try and get some else if and some for loops. I think for now we're just going to do the basic for loops, no funny range-based stuff or anything like that, just a simple for loop. And that should be enough flow control for now, I think. Cool. Thanks for stopping by. Don't forget to like the video if you want me to continue the series. And yeah, take it easy. Ciao for now.